all the depths of the sea, very few monsters rumored to exist could ever compare to the impossible behemoth, the bloop. But one name that took the internet by storm finally challenged the Lord of the Sea Monsters on a scale never before seen. Today on GojiCenter, we dive into the depths to explore this titanic rival to the biggest sea monster conjured by the thalassophobic minds of the modern age, exploring its history, speculative biology, and the nightmarish possibility if a bio-accurate version of this animal exists. And ending with a very anticipated announcement. GojiCenter presents El Gran Maja Explained. Now, some of you at home not familiar with what it is you're looking at here might be wondering where on earth did the legend of this nightmarish horror spring from? After all, it took an ice quake literally heard across an ocean to create the urban legend of the bloop, and sea monsters like the Kraken have had stories for centuries. So, from what depths did this terror spring forth? Simple, the most chaotic and wild realm of them all, the internet. Yes, indeed, El Gran Maja was the brainchild of the modern online age, brought to life by animators like its creator Borisao to make a new take on the classic sea monster formula. Extremely popular in the Latin American side of the net, El Gran Maja has destroyed submarines, battled other colossals like the bloop, and devoured ships and divers alike across hundreds of millions of views, exponentially increasing the number of thalassophobics around the world for years to come. So, before we take a stab at speculating the existence of a bio-accurate rendition of this sea monster, one which technically could exist, let's talk about the myth first. Raw stats. Length 2,214 feet or 674 meters. Jaw span approximately 165 by 250 feet. Tooth length more than 49 feet. Total mass 955,798,000 kilograms. That being more than 1 million tons. El Gran Maja definitely lived up to its name, dwarfing even the mighty bloop in terms of length and overall size thanks to a body over half a kilometer long. Nose to tail, this leviathan dwarfs most other serpentine kaiju, being more than double as long as Titanus Tiamat and Manda, while being many times heavier. With teeth longer than Godzilla's head and jaw span wide enough to fit him and Kong inside, El Gran Maja would be a force to be reckoned with in almost any cinematic universe, and could be considered a living natural disaster on its own. As mentioned already, volumetric analysis shows that this thing might weigh well over 1 million tons. If it thrashed about, swam at the shore, or even just simply made a sharp turn near the coast, it would cause a tsunami. There's a good reason why when it and the bloop noticed each other, everyone involved wisely chose to do two things: stay out of the way and let them fight. Thankfully for thalassophobes everywhere, something like this could never exist in our more mundane world. One of the reasons you don't see sea monsters like this roaming about even in the fossil record is food. As viewers might recall in our bloop analysis video, everything has to eat, and everything needs calories to keep going. Whereas the bloop is like a whale, its rival more resembles a fish like an eel. Most fish are cold-blooded and don't need to eat nearly as much as mammals do, since they don't need to burn energy constantly to heat their bodies. How much exactly they need to eat can fluctuate a lot depending on where they live and how often they move around. To help you understand that not all underwater predators eat as much as you think, here's a fun little fact for you. Greenland sharks and great white sharks can get to around the same size, but hunt and live very differently. Greenland sharks are cold-blooded and live in cold water, moving and acting slowly over an extremely long lifespan. A study from 2022 showed that they can get by on a fraction of the calories that a great white needs, but the greatest of the great whites with a hotter-blooded metabolism and constantly moving around still need a fraction of the fuel a mammal needs. Another study by David C. Burnvey found that the amount of food a great white shark needs per kilogram of mass actually decreases with size. The bigger the shark, the easier time it had stockpiling food and traveling against water resistance. A massive shark like Deep Blue only needs around 4.5 calories of food per kilogram of mass. That's about 5 to 8 times less than a human needs per kilo. And they call sharks voracious eating machines. Back to El Gran Maja though, we can see in the video that it is a pretty active predator, so a modified formula for great white metabolism makes the most sense to give us an idea of how much this monster eats. The results yield a staggering number of almost 700 million calories in a day just to maintain itself. If you remember from the last video talking about the bloop, you'll realize that this is a fraction of the amount the mammalian bloop needs, but still an astronomical amount. Maja, however, is typically found in more tropical waters around the equator, such as the Caribbean islands. Whales here don't even get half as big as the larger blue whales in the Antarctic Ocean due to factors like less food and needing to travel often. Daily, El Gran Maja would need to scarf down 10 humpback whales and still have room for more. If snacking on humans, the number is even more extreme. The average human contains 125,822 calories, if eaten. This means El Gran Maja would need to wolf down and perfectly digest around 5,200 people daily. And if this still sounds remotely plausible, there's another issue. Arguably, the biggest problem when you take something like this into reality is not eating, but getting to eat. The biggest problem that something like El Gran Maja might face is how it swims. Slithering back and forth in the water like a worm or sea snake is called anguilliform propulsion. Great for maneuverability, terrible at propulsion. The side-to-side shifting wastes a lot of energy and speed. Couple that with the infamous grin on this monster, full of big, empty, forward-facing pockets next to the teeth, and a predator bound by reality would have a hard time building up or maintaining speed enough to catch worthwhile prey. This is why a high-speed pursuit predator like the mako shark employs the thuniform swimming method. With a stiffer body and flexible tail for propulsion, this animal can move faster and easier than an animal with the same anatomy as the Gran Maja. So, basically, an animal like El Gran Maja, even if it could grow to be this big, wouldn't be able to sustain itself easily, especially if it has to move like this while being able to grow at this scale. So, this makes us think, what if across the seas of space and time, nature tried to engineer a nightmarish horror that fit the bill for this celebrity creature? Well, turns out something similar on a much smaller scale did once exist in the past and even has some uncanny families still around today. If taken to the absolute extreme with perfect conditions, the seas might well turn red from a giant maw. Cyclostomi, or jawless fish, are some of the most ancient vertebrates to ever exist, with meat-shredding hagfish and blood-sucking lampreys being two modern examples. Far back in the ancient oceans, one of their cousins became some of the most successful fish to ever exist. Conodonts are a whole lineage of jawless fish that roamed the seas in huge numbers for nearly 300 million years. With possibly the sharpest teeth to ever exist, taking one of these and allowing evolutionary natural processes and mutations to do their work would be a good start. In our own world, conodonts died out shortly after the end of the Triassic period, not long after one of the top 5 biggest mass extinctions of all time that wiped out the greatest marine reptiles ever. But in this scenario, a few of these razor-toothed predators got a stroke of luck. This right here will be the ancestor of our speculative Bio Accurate GRAN MAJA. They would start out with a very flexible body and minimal fins, just like other conodonts and their modern kin like lampreys and hagfish. Great for fitting in crevices and swimming at moderate size as filter feeders and small predators. But as these carnivores started targeting bigger game and traveling longer distances, some things will inevitably change. Swimming the seas in the way these small creatures do will not work too well for an animal that's really big. This is why we don't have extraordinarily large whales and sharks shaped like this. So as these predatorial conodonts grew in size, their form had to be gradually restructured. Over time, these deep-sea predators would have evolved special muscles that flex and stiffen the front half of the body. This would keep their heads straight when swimming to cut through the water easier with less wasted energy rocking side to side. Larger fins on the tail increase propulsion, and ridges on the head evolved to extend to the sides and stiffen. This not only gives our beast the iconic shape of El Gran Maja's head, but it gives a practical use in steering. Like the fins on a manta ray, tilting and shifting, these can help the apex predator turn on a dime and quickly redirect its head. Over time, these animals would adapt to swim using the carangiform method, a halfway point between the two prior methods discussed. This is good for balance of flexibility and bursts of speed. But to grow larger and to help it in pursuit or ambushes, it will have to develop something called pseudo-siphons. Similar to the jet propulsion used by a squid, a trait not usually seen in fish but having a real-world biological basis. Unlike other fish which manually pump water in and out of themselves with their mouth, lampreys have specialized muscles controlled with synchronized commands from the brain. Water is pulled in and pushed out through the pores in a steady pace. These vampiric predators use this to help breathe even while feeding on their bloody meals. For our currently evolving Bio Accurate GRAN MAJA, a more specialized, refined version of this trait will help out in filter feeding, and then was taken to the next step with all the water being directed out in one output instead of multiple. Focused out of a flexible cartilage nozzle on a swivel, quick bursts of movement out one side or the other. What first evolved to help with breathing has been adapting and retrofitted to help out with propulsion. But how can an animal like this evolve adaptations that are similar to animals like squid, despite being a completely different animal class? Simple. This would be another of the many classic cases of convergent evolution, where unrelated life forms confronted with the same problems develop similar solutions. Literally the same reason why dolphins and sharks have streamlined bodies and fins despite being in two completely different animal groups. In this case, our Bio Accurate GRAN MAJA sucks water rapidly through the mouth and extra gill ports before being redirected and shot out of the siphons. Perfect for rapidly lunging out to grab prey and sucking in plankton and schools of fish into the maw. El GRAN MAJA, as the urban legend has it, has a pretty frightening maw. Well, it just so happens that the likely ancestor of our speculative GRAN MAJA may have a more or less more frightening set of teeth, depending on what you consider scary. A likely ancestor of this animal would have been the Panderidus, sporting multiple rows of retractable, finely serrated fangs instead of true jaws. These teeth and the interior skeleton are actually synthesized from minerals filtered out of the seawater, adding extra strength to their structure. Over time, this maw would have remained similar, but as this animal evolves into gargantuan proportions, and as it latched onto larger prey, these fangs would reach frighteningly large sizes, helping it filter large schools of fish and krill, and if the opportunity knocks, it can latch onto and then stab into larger game with an extra deadly trick to call upon. We'll reveal this trick soon, but at this point, we have covered enough of this animal's ancestry to introduce Bio Accurate GRAN MAJA's true form. Ladies and gents, we present Thalassophobic octena, named after the horned serpent of Cherokee legend, who inflicted pestilence with its breath and shined with eerie lights. This jawless fish evolved to resemble characteristics of its urban legendary counterpart, and we're about to see how. Measuring a possible length of up to 200 feet with a mouth gape of up to 16 by 22 feet, its largest teeth measuring up to 10 feet, and backed up by a mass of up to 260 tons. For senses for both shallow and deep water, the Thalassophobic comes sporting not 2 but 4 acute eyes for picking up light and shapes at a distance. This might seem bizarre, but several types of fish have the same sensing organs developed from the brain that function just like extra eyes. This apex predator also can detect sense and water pressure changes with the elongated tentacles coming from its face. And like many deep water fish, this can manipulate a protein called luciferin, allowing it to light up parts of its body to confuse or attract prey to it. Now we can discuss the trick we mentioned before. Once biting into a prey animal, let's say an overly curious sperm whale foolish enough to swim too close, this predator has grooved teeth able to direct a potent anticoagulant venom into prey. This trait is reminiscent of some prehistoric conodonts, with a different kind of chemical weapon also seen in modern-day lampreys. This keeps the blood of a victim from clotting easily, leading to catastrophic blood loss. Large predators often hunt down large game using ambush tactics, attacking from below upon detecting an unsuspecting victim. Sharks, mammals, marine reptiles, and other species of fish all use this same hunting methodology. Similarly, as the Thalassophobic ancestor evolved, it would have adopted this same hunting methodology. Millions of years later, this animal now hunts whales in the exact same way. Leveraging its pseudosiphons to give it a quick burst of speed, Thalassophobic could rapidly ambush from below and leave a grievous wound. Even if the prey managed to flee, its predator would never stop chasing it. However, all big animals do not start out that way, and the young would be vulnerable to many natural predators like sharks. That is, if they didn't have another defense to call upon. The closely related hagfish are sometimes called slime eels for a reason. With specific pores embedded in the skin, these fish can release a fibrous slime when they are attacked. Similarly, as the Pandaridus began to take form as the Thalassophobic ancestor, the individual specimens that began developing a mucus-like slime began fending off predators successfully. These would reproduce and pass on the traits necessary to fend off predators even better, preserving their lineage. This slime can expand 10,000 times their original volume in less than half a second, gumming up the gills and teeth of attackers. Given this animal's sheer size and volume, this means most attackers like parasitic fish wouldn't even bother trying to bite Thalassophobic even when it goes through hibernation cycles. This is an invaluable asset to have in a fight against another large predator as they grow. Living mostly in tropical and subtropical water around deep-sea trenches, Thalassophobic would mostly spend its time switching back and forth between filter feeding in the water column, resting at the barren bottom during lean times, and hunting large game at the surface at night. During the bountiful times of year, these predators spawn near the infamous Sargasso Sea, vast floating mats of buoyant seaweed full of plankton and fish spawn to feed on. Now note, an animal this big would be extremely rare, even given all their adaptations. It is likely that this creature would produce tiny offspring with only a minuscule fraction of these surviving to grow more than a meter long. An even rarer few with indeterminate growth, where a species never stops growing, and negligible senescence, where aging does not deteriorate their body, could break 5 meters or so as apex predators. In most cases, this might be as big as they'd usually get. Certain predator species like Humboldt squid have built-in mechanisms to mature quicker and smaller during times of scarcity, trading in raw power for survivability. This might be one reason why these primordial predators survived as they did in this scenario, surviving major extinction events at a small size and then rebounding when abundance returned. And when conditions are perfect, 1 in a million of these sea serpents, perhaps even just 1 in a billion, can become true colossal sea dragons. And it is an even rarer event mankind might ever glimpse such a titan. In a world with this primordial of the seas, the Bermuda Triangle might have a whole new reason for shipwrecks. And who knows, given the incrementing global temperatures and deep water pollution, this animal may have to move further southward and hunt more at the surface, bringing it into conflict with both humans and perhaps another apex predator of dark, gargantuan size.